Gotta get down. It's Friday. Bellringer fans, living environment nutcases, and all of you other fans out there. Love having you tuning in to my Bellringers every day. And yeah, today, you know what we'll do today in the Bellringer? We go over the New York State Diffusion Lab. We've been working on it all week, as well as studying diseases during class. But this is one of those must-have labs that's required by New York State for all students in living environment. So I think it's a good chance for me to go over it with you. Plus, it's due today. Yeah. All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn on time. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. For this lab, we made fake little cells and we put them in our, fake cell. We put them in water and we added iodine to the water and then, you remember that what was going on in that lab, I think. And then we did some chemical tests. Anyway, let's look at what you should have got, what we did get, what we shouldn't have gotten, what should be on your lab report. First of all, you made this little fake cell. And inside it, you put glucose, and starch solution. And you wound up with this kind of milky white color on the inside of this cell. And then you took a cup and you filled it with water. And you added to that water iodine, which turned the water to this like orangey amber color. Not quite orange, not quite brown, not quite red, somewhere in between. Amber, we like to call it. And then it sat. You just waited a couple days, right? It sat for a while. While you were waiting, you did two chemical tests. The first one you used what was called Lugol's solution, which you know is iodine, which we've used before. And you tested water, glucose, and starch. And what you should have found is that when you added Lugol's to water, it turned that amber color. When you added Lugol's to glucose solution, it also turned that amber color. But when you added it to starch, it turned this dark bluish black color. Right? That was Lugol's test. That was the iodine test. And the second test you did was Benedict's solution. Benedict's was that blue stuff, and when you added it to water, you added it to glucose, you added it to starch, and then you had to heat it for a good 5 to 10 minutes. When you added it to water, you should have found that there was no change. You added it to starch, there was no change, but when you added it to glucose, it turned kind of this brick red, orangey red. It went from like blue to green to yellow to orange to red, right? That's positive for glucose. Right, so you did two tests. If it turned blue-black, that's positive for starch with iodine. And if it turns red with Benedict's, it's positive for glucose. Then you came back to your cell. And you should have noticed a couple of things with your cell. Right? You should have noticed that the inside of it turned that blue-black. The outside of it was no longer that amber color. Right? You take out the cell, the inside is turned all blue-black, but the outside is no longer really amber color. It's like that disappeared. Right? The inside was blue-black, outside was no longer amber color. You took some of the water that was outside of the cell and you did the Benedict's test. And you heated it up and and lo and behold, it turned color, which means it was positive for glucose. So what does this all mean? This all means when you started, you had iodine on the outside of the cell, you had glucose and starch on the inside of the cell. You let it sit. A couple days later, diffusion happened. Iodine diffused into the cell. Glucose diffused out of the cell. And the starch, although it may have wanted to diffuse, didn't move anywhere. It stayed inside the cell. Right? Glucose got out, iodine got in, but the starch got stuck. Of course, the big question is, why was the starch stuck when the other two could move freely? And the most likely reason has to do with size, right? The pores on the membrane are only so big. And we know starch are big polysaccharide molecules, big, huge molecules. They were probably too big to fit through the little openings in the membrane. Whereas glucose, a monosaccharide, much smaller, could fit through. And iodine, a little teeny tiny chemical, could have fit through. And probably water was going in and out too. during all this. So does that make sense? Like what we did with the lab, the New York State diffusion lab, every kid in New York State does this lab and should get the same results. Spoiler alert, on the Regents test, part D, they ask you questions based on this lab. Here, I'll show you a sample question. Regents question based on that lab. It says, the diagram below represents the distribution of some molecules inside and outside of an artificial cell over a period of time. And it tells you in the cell you have some water, you have oxygen, you have protein in the cell, and on the outside of the cell you have oxygen and water. Over time, right, you now have oxygen and water on the outside of the cell, and you still have glucose, oxygen, and water on the inside of the cell. All right, if you look closely, right, you can see that. So which one of the following statements best supported by this diagram? A, protein molecules are kept inside the cell because the cell needs them. B, oxygen molecules enter the cell over time by active transport. C, water molecules are too large to enter or leave the cell, so they remained where they were at the start of the investigation. Or D, the protein molecules are too large to diffuse out of the cell. Right, if you said D, you're correct. Protein would want to diffuse out, but obviously it can't make it through the membrane. Probably had to do with its size. There you have it, right? New York State diffusion lab. And it's Friday. Got to get down on Friday. Let's party for the weekend, all that stuff. All right, good day.